All right, so today, and I'm going to look at the test with you, but I'm not going to go through the test because that's not what your normal calculus teachers do. So I want to be as normal calculus teacher as ever. So I'm going to just show you the test, show you how many questions are on it, and I think there's 20 questions. And so anyway, this is basically what we're going to be doing, and this is called area under a curve. And I'm just going to go from A, well, we can go to A to B. Okay, there's the area under that curve or above that curve. And B to C, there's the area there. And then, of course, from C to D, area there. And then, of course, from D to E. So what we are doing in this next chapter, we are in Unit 4, okay? I skipped Unit 3. I'm getting to Unit 4 because Unit 4 is more important that you know how to do for 230 or whatever class is next, 230. All right, so I need to get y'all into antiderivatives, which is called integration. All right, and again, what we are doing is we're finding the area under a curve. So there would be A to B, B to C. Okay, there we go. B to C. Now the B to C and the A to B, those are important. I don't know why it did that, but anyway. That's areas under a curve. There's another one, I don't know why, there should be a, where's the bottom of the screen? It should be, okay. Let me see if there's another one right quick. Open. Area between two curves. There we go. This kind of helps out. Well, it's supposed to, oh, there we go. All right. Here's also how it turns out. Finding those areas right there. Now, we're not going to get into this, but this is where it's going with your 230. All right, when you take Math 230, you're going to be taking the area under two curves. And you see that it's not difficult at all. In fact, in some cases, like this problem right here, the algebra is very simple. You set them equal to each other, you find out where they cross, and then you do the antiderivative. So that's based on the antiderivative. This one's based on the antiderivative. And basically, antiderivatives, and write this down, antiderivatives or integrals give you the area under the curve. Are you still using the limit theory? Yes. You're taking the limit theory and you're putting it with algebra of the area of rectangles. And I wish I could show you that, but I don't have time to show you that right now. But you see that dark red line right here? You see that dark red line? That is called a rectangle, and it's very thin, okay? And the thinner you get that dark red line, the thinner you get it, the more accurate your area is. And I'll show you a little bit of that here in just a second. But as you can see, if we didn't have calculus, it would be very difficult to find the area under a curve. Okay, this is sine and cosine, which you don't need, but you can see, and in business, you're talking about the area under a curve when you get into marginal cost versus marginal revenue and all that good stuff. Okay? So, what I'm going to do now is I'm going to get out of this. I'm going to stop the recording, and I'm going to kick y'all out of class, and then I'm going to pull y'all back up, okay? Y'all with me?
Okay.
So I need y'all to X out of, make sure you X out of Skype for Business and go back in and make sure that you all are seeing green where it says availability. Make sure it says green before I pull you back in, okay?